Hello, welcome to another video from Aspiration International School, and today we'll be discussing a test paper that was assigned to the year 10s on chapter 3 to 6, which includes atoms, elements, compounds, and stoichiometry. Yeah? So let's start, and I will be showing the solutions to each question. Alright? This video should be premiered, so there will be a live chat. So if you want to ask any questions, please do so. I'll be there to answer your questions. So the first question. Do note that atomic number refers to the atomic number refers to the proton number, and nucleon number refers to the mass number. So in this case, we have potassium. Alright, we have potassium, and the number of protons, okay, are 19. The number of neutrons are 20, and if it's an atom, then the number of electrons would also be 19. But in this case, it is not an atom, right? So in this case, it is an ion. So what happens is the atom has donated electrons. So metals are substances that metal atoms are substances that donate electrons. Okay, so you're going to get potassium ions. So now the question is, how many protons, neutrons, and electrons are there in an ion of potassium? Well, the number of protons will not change because the only subatomic particle that changes, that is being moved around, is electrons, right? So here you can see electrons are being donated. So protons, there's no change. Neutrons, there's no change. All right. So the nucleon number remains at 39. There's no change. But for electrons, you had 19 and you donated one. So now you have 18 electrons, right? So the correct answer to this question is A. I hope this is clear. Do ask your questions in the chat right now. Okay, ask your questions and I will answer them in the chat. Slowly moving on to the next question. You will know that Q is a metal because of the electronic configuration. It's 2.1. So you know atoms with valence electrons of 1, 2, and 3 are generally metals. Alright? And P is a non-metal, alright, because of the electronic configuration of 2.7. So we know that this is fluorine, right? So P and Q, and of course we know that this is lithium, alright? So it's lithium fluoride. So P and Q combine together to form a compound, alright? So looking at a drawing, you will know that lithium will donate one electron. So then you're going to get Q. Once you have donated the electron, you are more positive. Once you have accepted an electron, you are negative. Alright, so if you were to write this compound out, it will be QP. Okay, but of course, by convention, we write the metals in front. I beg your pardon. So it's PQ, right? So this is considered the transfer of electrons. Now the transfer of electrons between metal atoms to non-metal atoms. Now this is a characteristic of ionic compounds. Alright, ionic compounds consist of metal cations and non-metal anions. Alright, so I hope this is clear. So this is an ionic compound and the formula is PQ. Therefore, the answer to this question is A. Now, I hope this is clear. If not, please ask your questions in the chat. We will slowly move on to the third question. So this question is about metallic bonding, alright, the bonding between metal atoms, okay, or the positive ions of the metals. So the definition, alright, the definition and the explanation to metallic bonding, alright, you will have a lattice of positive ions, alright, in a sea of free moving electrons, and there is strong attraction, alright, between the positive ions and the electrons. So this is why metallic bond is quite strong as well, right? So the answer to this question is definitely a C or a D because there is a lattice of positive ions. Now, do you remember what lattice means? Okay, it's a regular repeating pattern of particles. Okay, so particles that are arranged in an orderly manner, in a repetitive manner, okay, that is called lattice. So it's definitely C or D, so let's read the right column. A metal will react with an acid producing hydrogen. That is correct. That is correct. For D, a piece of metal can be molded into different shapes. Now, although, so these are both facts about metals and they are both correct facts, alright? But it's just that D is the better answer, alright? Because it's about explaining the metallic bond. So because there is a lattice of positive ions, when a force is exerted, the layers can slide over each other, which gives rise to the property of metals called malleability. So the answer to this question is D. Now, the positive ions, they form layers, alright? It's an orderly structure called lattice structure. So whenever a force is applied, the top layer can move. So pure metals are weak because they are malleable, because the positive ions are in layers, and when the force is exerted, the layers can slide, the shape will change. D is the best answer. Questions? We will move on to the next question. Keep your questions coming. Which statement explains why methane has a lower boiling point than water? So these are molecular compounds, okay, simple covalent molecules. Now, you need to understand that there are two kinds of covalent compounds. One is the macromolecules and another is the simple covalent molecules. So methane and water, they are both simple covalent molecules. So methane looks like this. So that those are three methane molecules. And water. Sorry. And these are three molecules of water. So now, these are covalent bonds. Do you know which bond is covalent? Right. So these bonds, they are covalent bonds. And covalent bonds are strong. Alright? Covalent bonds are strong. Now, these bonds, alright, these bonds, the bonds between the molecules, the bond between the molecules that I'm representing as dotted lines, those are intermolecular bonds. So the covalent bonds are strong, but the intermolecular bonds are weak, and that is the bond that we are talking about. So covalent bonds are strong. So immediately you know the answer is not A. Alright? So it's about weaker attractive forces than water. So the intermolecular bond of methane is weaker than the intermolecular bond of water. So the answer to this question is B. So know the difference between covalent bonds and intermolecular bonds. Ask your questions and I will slowly move on to the next question. So this is just a balancing equation question. So, being able to write out the formula for the compound would already narrow down the available answers, right? So you have iron and you have sulfate. So you will know it's Fe2 and SO43. So immediately you know that the answer is not A and B, alright? And the answer could be C and D. So immediately you will know the answer is C because here it says that a solution. So solution is aqueous. So immediately you know the answer is C. Right? But let's read on. Yeah? Reacts with aqueous sodium hydroxide to form a red-brown precipitate. Yeah, you just have to look at the balancing. Yeah. So yeah, and the strange thing about D is that you have liquid. What's the difference between liquid and aqueous? All right, liquid means molten. All right, and it's quite difficult to get molten iron sulfate and molten sodium sulfate in D. So C is the clear answer. All right. So it's about balancing the equation and understanding that for ionic compounds they have extremely high melting point. So you can't just get molten just like that. And anyway, it states solution. All right. So to form a red-brown precipitate is a solid. So you got to make sure that one of your product is a solid, which they both are. So they are really testing you on aqueous and liquid, and for you to know the difference. So two things here. All right, balancing the equation and understanding the difference between aqueous and molten. Any questions? Please put them in the chat. Let's move on. So you will understand that they are all gases. You can see that they are all gases. So if they're all gases, that means that the moles, all right, is proportional to the volume, like directly proportional. All right. So you have N2 and 3H2 and 2NH3. All right. So you have 0.75 moles of hydrogen. So how many moles of nitrogen do you need? Well, it's 3 to 1, so you divide this by 3, you're going to get 0.25. How many moles of ammonia is being produced? Well, 3:2, so it's 0.5 moles. Alright. So what's the volume of ammonia gas? So the maximum volume would be 0.5 times 24. Alright. So that's 12. And to change it to centimeter cube, you multiply by 1,000. But be careful, the answer is not C, because you got to multiply with 30%. The yield is only 30%. So now you've got to take 30% multiplied by 12,000. All right, and what would that give you? All right, so the answer to that question is most probably A. Alright, so this is stoichiometry for you. So if you have any questions, do ask them now. In the meantime, don't forget to subscribe, like, and press the bell so that you will get notifications on the latest videos that we post on our channel. Okay, if there's any questions, please put them now. If not, I'll move on to question 7. So this is a qualitative question. Let's look at each one of them. Let's look at A. So, fluorine. You know that fluorine is 2.7, so it's going to gain 1 electron. So A sounds like a right answer. B. Yep, it's only going to get 1 electron and you're going to get F minus. B. Each fluorine atom gains 2 or more electrons. No. It has to be a definite number. It can't be 2 or more, right? So it's just 1. C. The fluorine atom loses electrons. No. Metals lose electrons. Non-metals gain electrons. No. D. Each fluorine atom loses. No. Only metals lose electrons. Non-metals gain electrons. So it is very clear that the answer to this question is A. Alright? So remember, alright, you will have the periodic table with you. Alright, you will have the periodic table with you. So you can get the electronic configuration from there to see the number of electrons a particular atom, is going to donate or accept in an ionic exchange. Alright. So metals lose electrons, metal atoms lose electrons, non-metal atoms gain electrons. So the answer to this question is A. I hope to see more questions in the chat. So if you have any questions, please put them down. Carbon-14 and carbon-12 are isotopes of carbon. I hope you know what isotopes are. Isotopes, alright, they are different versions of atoms of the same element, right? Same element, different versions, alright? Same proton number, but different number of neutrons, so different nucleon number. Let's have a look at each of them. A. Alright. First of all, the reactivity, I think they're talking about radioactivity here, but we know that carbon-14 is the radioactive isotope, so A is definitely out of the question. Yeah, but we know that carbon-14 is more radioactive, so B is not the answer. Alright. C, the reactions are similar because they're the same number. Absolutely right. You will know that the chemical behavior of a certain element depends, alright, or between two atoms, two substances, depend mainly on the number of valence electrons. Yeah, the chemical behavior depends on mainly on the number of electrons on the outermost shell. Alright. So I think C and D is very close. Alright, but of course we know that chemical behavior depends on the number of valence electrons. So the answer will be C. Just remember that. Chemical reactions depend on the number of electrons on the outermost shell. Let that sink in your mind. Don't make this mistake. More questions? Now, since this is about bonding pairs, now for the uninitiated, it is highly recommended that you draw the dots and crosses diagram, which I will attempt to do right now. So, hydrazine it is. So, you will have two atoms of nitrogen. So, you know that nitrogen is 2.5. If you have 5 electrons, that means you will need to share 3 electrons. So, you have 5 and you will share 3 electrons. So, these are the 3 electrons that you will share. So you have 2 non-bonding pair of electrons. Alright, so the nitrogen has 1 pair of non-bonding electrons. So 1 non-bonding pair. Alright, and so each nitrogen will have, oh dear, 3. So 1, 2, and 3. Alright. Hydrogen, 1 valence electron, only 1 electron, so it will need to share 1 electron. So it will share, and it will share. So this is how it looks like. So hydrogen has no non-bonding pair. Let's go through each of the answers. A. Each nitrogen atom has a non-bonding pair. So this is correct. B. Each nitrogen atom has 4 bonding pairs. 1, 2, and 3. Now, no. 4 bonding pairs. So there's only 3 pairs of 3 bonding pairs. So B is incorrect. Let's look at C. Each nitrogen atom shares 1 electrons with a nitrogen atom. Yes, each nitrogen shares 1 nitrogen with the other nitrogen, so it's correct. D. Each nitrogen atom shares 2 of its electrons with the hydrogen atoms. That's absolutely correct. So the answer to this question is B. Solid X has a high boiling point. Its structure has positive ions surrounded by a sea of electrons. Immediately we know that this is a description of the bonds of metals. So X is a metal. What other properties does a metal have? You know that brittle and malleable, they have the opposite meaning. Okay, malleable means it can be shaped. Brittle means it cannot be shaped. What is brittle? Imagine you have a pencil, all right, and you bend. The pencil will break. That is the meaning of brittle. But brittle does not mean weak. The common misconception is that people think that brittle is weak. No. For example, if you have diamond, all right. Now, if you apply force, diamond is a very, very strong substance. Sometimes it just will not crack, right? So if it does not crack, it will stay in shape. That is also the meaning of brittle, all right? So brittle means that the object does not is not easily shaped by a force, all right? You can't bend it like a metal. So 10 is a metal, so it's definitely C or D. And we know that metals are electrical conductors. This is basic science. So the answer to this question is definitely a C. Metals are malleable and they conduct electricity. So that is clear. Let's look at A. Aluminium oxide, Al3 plus O2 minus. Cross it down, Al2O3, A looks fine. Let's look at B. Iron 2 plus. The Roman numeral next to certain metals, they indicate the charge on the metal. So it's Fe2 plus. Nitride is 3 minus, all right. So it's Fe3N2. So B is incorrect. Let's check out C. Sodium and sulfate crisscross. So you're going to get Na2SO4. So C is correct. And lastly, D, zinc nitrate, Zn2 plus NO3 minus. So ultimately, you're going to get ZnNO3 2. So D is absolutely correct. Now that's how we do this. That's how we determine the formula of ionic compounds. Any questions, please? Do ask your questions. I will slowly move on to the next question. So you're given an equation and they're asking you for the volume of gas. Now there are two gases there, nitrogen, and the oxide of nitrogen and oxygen. So which volume of gas is produced when you have 0.1 moles of magnesium nitrate being decomposed? Well, if you are given the moles, you will know that you have 2 moles of magnesium nitrate and you have 5 moles of gas, right? You have 5 moles of gas. You got 4 moles of nitrogen dioxide and 1 mole of oxygen. All right. So 2:5. Okay. So now if you have 0.1 moles here, how many moles of gas which you have? So this is just purely ratio. Okay. So this is 0.25 moles of gas. So how do you find the volume of gas? Well, volume is equal to 0.25 times 24. So it will be 6 decimeter cube. So the answer to this question is C. Well, the only complicated part is you need to take 4 and add it to 1, so you're going to get 5 moles. So you have to understand that there are 5 moles. If there are 2 moles of gas here, there will be 5 moles of gas produced. So the ratio is 2 to 5. So the answer is C. So the formula for the volume of gas is the moles multiplied by the molar volume, which is 24. Moving on. Now we have come to paper 4, the structured questions. Now, this question is about elements X, Y, and Z. So let's start with X. Alright. So, question 13. So you have X as 1634. Right. So how many protons do you have? 16, and if this is an atom, you will have 16 electrons as well, and the number of neutrons is 18. All right. Name the different types of particles found in the nucleus. Name the different types of particles. Well, in the nucleus, you will have proton and neutrons. What is the term for the total number of particles in the nucleus? Well, this is the nucleon number. So whatever is in the nucleus, alright, contributes to the nucleon number. Alright. So nucleon is like the adjective for the nucleus. Okay, so nucleon number. This is clear. This is very introductory. Okay. Moving on. Part 3. What is the total number of particles? The total number of particles found in the nucleus? Well, that is the nucleon number, which is on the top left corner of X. So this is just 34. So this question is just really testing you on your basics. Okay? Testing you on your basics. So this is the proton number and this is the nucleon number. Although there are 16 electrons, but you can't say that this is the electron number. Alright, so how do we get the number of neutrons? Well, this is the nucleon number. So 16 plus something will be the nucleon number. So it will be 18. How do you get 18? You just take 34, subtract with 16. Alright, so the number of particles in the nucleus is the nucleon number. It's 34. What is the electronic structure of the ion X2 minus? Alright, so you know that the atom of X is 2, the electronic configuration of the atom of X is 2.8.6. So X2 minus means that you are more negative, means you have accepted electrons. How many more? 2. So the electronic configuration is 2.8.8. Lastly, suggest the formula of the compound form between aluminium and X. So again, to do this question, you need to know the charge on aluminium. So it is Al3+, right? And X, it's 2 minus, so you need to cross it out, right? So 3 and 2. So ultimately, the answer will be Al2 and X3. So this is the answer to part 5. So again, this is really testing you on your basics of the types of particles in the nucleus and how many there are. Okay, if you are given a nucleus symbol and electrons, right? So you know that a certain particle a certain atom, right, it does not transfer protons or neutrons. They only transfer electrons. So the proton and the neutron and the nucleon number do not change. Only the number of electrons. If you have any uncertainties, do let me know. Moving on. Alright, I think we attempted this question in the multiple choice. So, different versions of atoms of the same element. Alright, so the answer to this question is isotopes. B. Identify the atom against which the relative masses of all other atoms are compared. You will know that all the masses of all atoms are compared to the atom of carbon 12. What is the name of the amount of any substance containing 6.02 times 10 to the power of 23 particles? What is the name of the amount of any substance that contains this amount of particles? Very basic, right? This is the mole. Okay. And 6.02 times 10 to the power of 23 has a special name. Anyone can guess this name. Put them in the chat. Let's see who gets it first. So this is the Avogadro. Alright? So it's Avogadro's constant. So on that line you should just write Avogadro without the apostrophe in it. So I hope this is clear. Alright? Basic question. Basic chapter 3 stuff. Okay, this is a bit tricky. This is a bit tricky. So the definition of the relative atomic mass is given there. It's the average mass of naturally occurring atoms. Naturally occurring because now it seems that they can synthesize atoms. But we are talking about naturally occurring atoms. So the relative atomic mass is the average mass. Alright, meaning for a particular element, for example sodium, you can have different versions of sodium. You can have sodium 23, you can have sodium 24, but the number that is found in the periodic table is the relative atomic mass, which means that it is the average. So the numbers that you see, the mass numbers that you see in the periodic table, they are all relative atomic mass. It means that they are all the average of different versions, alright, of the atoms of the same element. So we're going to try a question out. So you have two isotopes here, Y, which is 69, and Y 71. Alright. Now the ratio in abundance is given. Okay. Yes. Of all the Y atoms that are present on this planet, okay, 3/5 are Y69 and 2/5 are Y71. Alright, so 3 to 2. So how do we calculate the average for the mass of Y? Alright, so this is how we do it. Alright, so for part C, the first part, alright, so you're going to take 69 times 3 plus 71 times 2. What would that give you? So that's 349. So the average is you take 349 divided by, please don't say 2. Yeah, well, teacher, we're talking about 69y and 71y, so there's two of them. So we divide by 2. No, you divide it by 5 because it's 3 and 2 parts. So this is a common mistake. Yeah, so it's 5. So this is 69.8. Okay, so in IGCSE, the That's why in A levels the periodic table comes with decimal places because it's the average, right? You tend to get decimal places, but in IGCSE it's rounded off, okay, as 70. And if you have your periodic table with you and you check it out, most probably the element with a relative atomic mass of 70 is gallium. So if you have any questions, do let us know, do let me know, and I can address them. So look in the periodic table, alright? I think there's only one element with the nuclear number of 70 or the mass number of 70, and that element should be gallium. We'll pause here for a while, keep your questions coming in, because this is an unusual question in IGCSE. You know, I've seen it before, in Pearson and Excel papers, but very rarely in Cambridge. So this is one of the few relative atomic mass questions in Cambridge. So do look at it and do let me know any questions you have. For this question, you will need the periodic table, and you can get the periodic table from any chemistry textbook, right? Period 3, period refers to the horizontal rows and group refers to the vertical row. So period 3 and group 5. It's, what did you get? Let me know in the chat. Yes, it's phosphorus. Explain in terms of electron transfer why Z behaves as a non-metal. Alright, now why? Alright, now it has valence. It has valence electrons. It has 5 valence electrons. Okay, so it will accept 3 electrons. So you know that non-metals, alright, non-metals accept electrons. So this is why phosphorus behaves like a non-metal, because it accepts electrons. You need to understand that metal atoms, alright, donate electrons. So metal atoms donate electrons, non-metal atoms accept electrons. So this is why phosphorus behaves like a non-metal, because it accepts electrons. Okay? So I hope this is clear. Now we are moving on to the next and final question, if I'm not mistaken. Yeah? Again, from the multiple choice, you can get some of the answers already. So here we have number 14A. The name is, this is magnesium, it is a metals. What's the name of the bonding in metals, right? So the name of the bonding is metallic bonding. Metallic. And the description, alright? So the description is what we have done earlier, a lattice of positive ions, right? You can refer to our earlier discussion. You have a sea of free moving electrons, and there is strong attraction between the positive ions and the sea of free moving electrons. So this is how you get 4 marks for this question. Let me know if you have any questions. Okay. The dots and crosses diagram. Magnesium oxide is formed when magnesium burns in oxygen. So to complete the dots and crosses diagram, showing the electron arrangement in magnesium oxide. So normally, well, usually they want you to show them the electrons in the negative ion, but I guess in this question you need to show in both. Alright, they used to only want the electrons in the negative ion, but now they want them in both. So you need to refer to your periodic table, and you need to know that magnesium is actually 2.8.2, so you donated 2 electrons, so you have 2.8. So this is given, and then you need to illustrate the other 8 electrons on the outer shell. So you have lost 2 electrons, so your charge is 2 positive. Right? Make sense? Okay. Now for oxygen, you have 2.6. Alright? So now you're going to get 2 more because you want a full outer shell. See, they both want full outer shells, and it's 8. Okay? So, 2, and you have 6 initially. 1, 2, 3, 4, 5, and 6. And now you got 2 from magnesium. So now you've got 2 extra electrons, so your charge is 2 minus. So this is how you draw the dots and crosses diagram for magnesium oxide. So 2 electrons has been transferred to the oxygen atom. Let me know if you have any questions. Okay, stoichiometry for you. So a balanced equation between magnesium and oxygen. So remember, being able to write out the formula and eventually the equation and balancing the equation, it's pivotal. Alright, in stoichiometry, you are not able to attempt any stoichiometry questions if you are not able to write the formula, if you are not able to construct an equation and balance the equation. Right? So magnesium plus oxygen. So you got to know that oxygen exists in diatomic form, right? You need just something that you just need to know. All right, and this is magnesium oxide. Why? Because the charge is 2 and 2, so you cross it down, it simplifies to 1 and 1. So this is the unbalanced equation, so you need to balance it. So now you have a balanced equation which states that 2 moles of magnesium react with 1 mole of oxygen molecules to produce 2 moles of magnesium oxide. Part 3. So now we are told that 76.8 grams of magnesium. So there's 76.8 grams of magnesium here, and they completely react with excess oxygen. Alright. So if you have 100 grams of magnesium oxide formed, calculate the percentage yield. I've told my students countless times that if it's percentage yield, you do not make use of the mass that is provided, the mass of the yield that is provided. So we do not use the 100 grams to calculate the moles. You only use it at the end. So the moles of magnesium reacted, well, to do this question, moles equals to mass over mR, right? So it's equals to 76.8 divided by 24. So at any point, if you don't understand, do pin your thoughts down in the chat. Yeah? So you have 3.2 moles. So the maximum moles of MgO that can be formed. Well, since this is 2:2, alright, so the maximum moles is also 3.2 moles because the ratio is the same, 2 and 2. So the maximum moles you can get is also 3.2, the maximum moles of magnesium oxide. So what's the maximum mass of magnesium oxide that we can get? You will see that the molecular mass is already given there. So mass equals to moles times the mR, which is 3.2 times 40. So the maximum mass that we can get is 128 grams. So what is the percentage yield? So the percentage yield is the mass that you got in the lab, alright, which is 100 grams, over the maximum theoretical mass that could have been obtained, and you multiply it by 100. That's the formula of percentage yield. So it's 78.125%. So this is how you solve a percentage yield question. Let me know if you have troubles comprehending this question, please. So there you have it, from constructing the equation to calculation of the moles and the mass, and therefore percentage yield. Do let me know if there's something I can help you with. At any time, if you're facing any problems, you can always contact us. Our phone number is there, our Facebook and Instagram account is there. Do reach out to us, follow us on social media, and we are always within reach. Moving on. Oh, we have come to the end of this paper. Now, for those who are watching, thank you so much for your support. Do not forget to click subscribe and like this video, and we'll see you in the next video. Thank you. Bye bye.